Welcome to the Iris Logic YouTube channel, where innovation meets intelligence. Today, we delve into the captivating world of generative AI, a groundbreaking technology that's reshaping the way we create and interact with content. What is generative AI? Generative artificial intelligence, or generative AI, is a revolutionary concept that empowers us to create new content rapidly and seamlessly across a wide spectrum of mediums. With generative AI, inputs like text, images, sounds, animations, 3D models, and more can be transformed into entirely new forms of creative expression. So, how does it work? Generative AI models utilize neural networks to decipher patterns and structures within existing data, enabling them to craft entirely original content. These models are trained through unsupervised or semi-supervised learning, allowing organizations to harness vast amounts of unlabeled data and create foundation models. Meet foundation models like ChatGPT and Stable Diffusion. These models enable the power of language to create essays from short text requests or photorealistic images from text inputs. The success of a generative AI model depends on three essential factors: quality, diversity, and speed. These factors are crucial for ensuring that the AI model produces high-quality outputs, offers a wide range of variations, and operates efficiently in terms of processing speed. Quality, ensuring high-quality outputs for seamless interactions. Diversity, capturing diverse data modes while maintaining quality. Speed, generating content quickly for real-time applications. How to develop generative AI models. There are multiple types of generative models, and combining the positive attributes of each results in the ability to create even more powerful models. Diffusion models, also called denoising diffusion probabilistic models, are a type of generative model. They work by training in two steps. 1. Forward diffusion, noise is gradually added to the training data. 2. Reverse diffusion, the added noise is removed to reconstruct the original data. A diffusion model can take longer to train than a variational autoencoder (VAE) model, but thanks to this two-step process, hundreds, if not an infinite amount, of layers can be trained, which means that diffusion models generally offer the highest quality output when building generative AI models. Additionally, diffusion models are also categorized as foundation models because they are large-scale, offer high-quality outputs, are flexible, and are considered best for generalized use cases. However, because of the reverse sampling process, running foundation models is a slow, lengthy process. Variational autoencoders use two neural networks called the encoder and decoder. When you provide something as input, the encoder makes a condensed version of it. This keeps the important details needed by the decoder to recreate the original input, while getting rid of the unimportant stuff. The encoder and decoder work together to learn a useful and simple hidden representation of the data. This lets you easily create new hidden patterns. The decoder can then turn these patterns into new data that you haven't seen before. VAEs can produce outputs like images more quickly, but the images they create are not as intricate as the ones from diffusion models. Generative Adversarial Networks, GANs, discovered in 2014, were the most popular method among the three until the recent rise of diffusion models. GANs involve two neural networks competing, a generator that creates new examples, and a discriminator that learns to tell whether the generated content is real or fake. The two models are trained together and become more advanced as the generator produces improved content and the discriminator becomes better at identifying generated content. This process is repeated, encouraging both to enhance their abilities with each round until the created content looks just like the existing content. While GANs can produce excellent samples and generate outputs rapidly, they struggle with generating diverse samples. As a result, GANs are better suited for generating data specific to a particular domain. Another important aspect of developing generative models is the underlying architecture. One of the most popular architectures is the transformer network. Understanding how this works is crucial in the context of generative AI. Transformer networks. Transformer networks are designed to process sequential data in a unique way, distinct from recurrent neural networks. Two key features make transformers highly effective for text-based generative AI tasks: self-attention and positional encodings. These elements enable the algorithm to capture relationships between words across long distances and represent the sequence's timing. Self-attention involves assigning importance weights to different parts of the input, indicating their relevance within the context of the whole input. Positional encoding represents the order of input words. A transformer consists of multiple transformer blocks, often referred to as layers. These include self-attention layers, feed-forward layers, and normalization layers. They collaborate to interpret and predict sequences of tokenized data. This data could encompass text, protein sequences, or even image patches. What are the applications of generative AI? Generative AI is a valuable tool that can enhance the efficiency of various professionals, including creatives, engineers, researchers, and scientists. Its applications are diverse and can be utilized across different industries and by individuals. Generative AI models have the capability to take various inputs such as text, images, audio, video, and code, and generate fresh content in any of these formats. For instance, it can transform text inputs into images, convert images into music, or even change videos into text. Generative AI is used in different areas like language, audio, visual, and synthetic data. Language, text serves as the foundation for many generative AI models and is a highly advanced field. Large language models, LLMs, are a prime example. They are used for diverse tasks such as generating essays, coding, translation, and interpreting genetic sequences. Audio, generative AI is also making strides in music, audio, and speech. Models can create songs and audio clips from text inputs, identify objects in videos and add corresponding sounds, and even craft custom music compositions. Visual, a major application of generative AI, lies in image generation. This includes crafting 3D images, avatars, videos, graphs, and illustrations. The technology allows for diverse artistic styles, as well as methods for editing and altering generated visuals. Generative AI can generate graphs illustrating novel chemical compounds for drug discovery, create realistic images for virtual or augmented reality, generate 3D models for video games, design logos, improve or modify existing images, and more. Synthetic data is really helpful for training AI when real data is missing, limited, or can't cover all situations accurately. Making synthetic data using generative models is a big solution for companies facing data challenges. This method, called label-efficient learning, works for all types of data and uses. Generative AI can make training easier by creating extra data or learning about data to train AI models better with less labeled data. Generative models have a big impact and are growing in use. Here are examples of how generative AI is changing transportation, natural sciences, and entertainment. What are the challenges of generative AI? Generative models are still in their early stages of development, and there's room for improvement in several areas. Scale of computing infrastructure. Generative AI models have a huge number of parameters and need fast data pipelines for training. This requires significant investments in technology and computing resources. For example, diffusion models might need millions of images for training, which demands powerful GPUs. Sampling speed. Due to their complexity, generative models might have a delay in generating results. This could be a problem for real-time applications like chatbots and voice assistants, where responses need to be instant. Lack of quality data. Generative models often need high-quality, unbiased data to function well. Some areas lack enough data for training. For instance, developing 3D assets is expensive, and there's limited data available. Data licenses. Getting the right to use existing datasets for training can be tricky due to licensing issues, and it's crucial to avoid intellectual property problems. Many platform providers are working on solutions to these challenges. They aim to support the growth of generative AI models by offering tools and services that make it easier to set up and run these models at scale. What are the benefits of generative AI? Generative AI offers several important benefits, including 1. Creating original content. Generative AI can produce new content like images, videos, and text that looks just like human-made. This is valuable for creative fields, advertising, and entertainment. 2. Enhancing existing AI. It can improve the performance of other AI systems. For example, by generating synthetic data to train AI models, generative AI helps in natural language processing and computer vision. 3. Exploring complex data. Generative AI allows businesses and researchers to analyze intricate data in novel ways. It uncovers hidden patterns and insights that might not be obvious from the raw data alone. For automation and efficiency, it automates tasks and processes, saving time and resources for businesses. This automation speeds up various operations. In essence, generative AI has a broad impact across many industries and applications, making it a vital field of AI research and development. Conclusion. Iris Logic has a skilled team of data scientists and engineers ready to assist you in developing your NLP and generative AI strategy. Our experts can guide you through cloud hosting for these models, handle ongoing data tasks like ingestion and transformation, refine and enhance models, keep track of progress, create impactful data visualizations, and tailor machine learning models according to your business needs. We've partnered with both prominent and startup companies to help them design, validate, and implement generative AI strategies that have significantly boosted their business results. Get in touch with us today to learn more.